Hello, learners. Hope you are keeping well. Today, we're going to do a little bit of revision on climate and weather. Now, we will be looking at the 2019 NSC November paper. Thank you, DBE. So we'll be using their paper. Now, from the outset, I've heard these comments on many times. You understand, from learners. Whoa, I did the papers and all my papers covered urban heat islands. And in the paper, they tested us on valley climates. I lost out. That is the wrong approach. Okay, why do we do revision? We do revision to get into the mind of the examiners. I don't mean hypnotize them so you can get the paper, but getting into the mind, looking at how they ask questions, how they use the resources, all right? And what sort of answers do they want? That is why it becomes so important to actually go through past papers set by the DBE, the Department of Basic Education, because it gives you lovely ideas. So it's about strategies. You understand? There'll be questions that are asked. Maybe it came out on Urban Heat Island. You can maybe take the same things and apply it to valley climates. You understand? Where does it occur? When does it occur? You understand? When is it more pronounced? Okay, so we're getting into the mind, and it doesn't matter what section comes out and what you practice. It's good to practice on all sections. That is why you notice on many of my videos, I did try to do work guides on all sections when I was teaching the content. All right, but sometimes if you just go through questions for the sake of just going through questions and seeing what the answer is and trying to learn the memo, it's not going to help that much. Okay, but looking at the strategies will teach you how to apply the information. And when you apply the information, you learn the technique. And you can get any section that you studied, because when you study, you are studying with application in your mind. So it's not about predicting the right section or spotting the right section that you think may come out. You understand? Came out that in that last year, now another section will come out now. It's about techniques, strategies, which will allow you to apply every section. Okay, so we're going to get into the minds of those people, okay, that set this thing, and we're going to look at how they structure. What do they want? Okay, so let's get going and keep that in your mind. Okay, so I may go through things today. So Dave did not do that one. He did a paper and this was not there. It's about strategies. Okay, right, so let's get going. Right, let's look at this, learners. And what we notice here, that one of the things we've noticed now, that we can get questions that don't have a resource, okay, in terms of a diagram, a table. So we must be prepared for this. We must be able to apply our information. And I do apologize for each revision lesson. I'm going to say the same thing about strategies so that I will drum it into your heads. So my introduction to any of my lessons will have the same thing. So by the end, when you're watching all my revision lessons, you are going to say, I'm sick of it. It's in my head. I'm going to do it. Okay, so that's going to be in every lesson. So let's look at this. There's no resource. And this is what brings our visual in. All right, now let's look at this type of question. Okay, let me get my highlighter. Okay, it says give one term for each of the following descriptions. Okay, there's the terms, there's the descriptions. By choosing a term from the list below, right? Only the term next to the question numbers. Example 118, and if you feel the answer is climate, obviously there's no 118 here. Please, learners, stick to the instructions, which is very, very important. All right, because if you start writing other things, it may not make sense. Okay, and there's no guarantee to be marked, so stick to the instructions. All right, so here our bit of our visual comes into our heads now. All right, so it says a zone where warm air mass is trapped between the colder air masses. Now, I'm not going to do the technique for each one, okay? But I'm going to do it for a few so that you get used to it. And as I do revision lessons on geomorphology and economic geography, I'll do a few. So what goes into my head? Yes, I've done inversion layer, I've done thermal belt, stuck or trapped between two cold air masses. And this comes into my head, eh? There's a cold air mass here, okay? Katabatic winds. And there's a cold air mass lifting the warm air, and the warm air gets trapped. What did we study this as? Thermal belt. Okay, so it's a visualization of what do I see in my head. And you know, this is where rote learning creates such a problem, because you don't visualize, you just take things in and stick it into your head and it stays there. Now I visualized, so I know, hey, I remember this. So 1.1.1 is my thermal belt. All right, this one is very straightforward, eh? You know fog, all right? It could be, some people call it a cloud near the surface because of condensation. And you know smog, okay? Smoke rather, not smog, I'm giving you the answer. When they mix, they create the grayish sort of fog, and it's known as smog, right? The direction in which the slope faces in relation to the sun's rays. Examiners have been really nice here. The direction, all right, and the sun's rays, immediately if you can visualize that the sun is shining, it is aspect of slope, all right, or aspect. Okay, forms when calm conditions and clear skies occur in a valley. All right, okay, you know, you've learned this. All right, when you looked at things, and you must make sense like this. For instance, we talk about terrestrial radiation coming off from the surface, and the air above cools, but this radiation can only come through and go up if the skies are clear. Can you see it? So you learn that again. Can you see how I'm making sense? I'm not just guessing. Radiation fog. All right. And you look at main words that the examiner gives you. Valley floor, okay? It does form part on the side of the valley floor. We don't contest that. We look at what the examiners are saying to us. You understand? Valley floor, let's look at another one. Air temperature is below freezing point, all right? Or when you learned when the dew point temperature is below freezing point, right? But the examiner gave you air temperature and below freezing point, all right? And you notice there's only one option here. You understand? And that is your frost. You know, you get frost occurring. Can you see it? The type of wind, now we're dealing with wind. Can you see the action words? Results from air sinking down a valley at night. You know, when it comes at night, it sinks down. You understand? The valley slope, obviously, that's katabatic winds, not just sinks into the valley, because that is any sort of subsiding air. It sinks down the valley slope at night, and there's no problem. It's katabatic. Can you see it? And examiners have been very nice here. All right, they give you the opposite. When the wind results from air moving up the slope during the day. Can you see these action words, learners? All right, And of course, you know that is anabatic when it goes up. Can you see? So it's not just about guessing. All right. Look at your options that are given to you. Can you see it here? Your options, all right, that are given to you, and see which one is the best. So work it out. You understand? Work it out in your head as you're going through. Work it out, all right, first, and then look at your options. Say, is it there? Okay, you may get somewhere, maybe challenges. What is it saying? I think it's this. You understand? Okay. And you look there, oh, there it is. All right. Don't just try to spot the one in the correct way, because these things you should be getting total for. You understand? These sections you can command it. So it's about working it out in your head and then looking at this. Okay. That's your first type of questions, learners. Let me go to another one. This is a case study. Okay, now don't please excuse the numbers, because it's the DB paper and I can't mess around with the numbering, etc. But you must remember, 1.1 is climate, 1.3 is climate. Now this is a case study. Okay, read carefully, because sometimes if you don't, it may just be a problem. Okay, so somewhere there is some hints. All right, there may sometimes be some challenges. It happens anywhere, learners, where gremlins do creep in into resources, etc. You understand? It can happen no matter how many times you check things, but you find a way to answer it. And always remember, don't get scared. You do it to the best of your ability. You understand? Because no learner gets disadvantaged. Okay, so look at this. If I had to look at this down here, I could take it as, oh, it's a distance that it moves. All right, and I don't look at anything else. Now, if I look at this, winds of 120 kilometers per hour, maybe it should have been written there, but it gives you something. Oh, I see. You understand? I see what's happening here. All right, as it's going in, you understand? This tropical cyclone that affected southern Africa is decreasing in speed. Oh, yes, friction. You understand? There's my Mozambique border. All right. Already I picked up, even without looking at what the paragraph is saying to me, I already, oh, I can see it here. You understand? I can see, and I know the isobars are getting further apart. It's starting to reach the stage where it dissipates. Can you see it? Dissipation. I know it down here. I can see it. And the wind speeds are decreasing. So I read everything. You understand? Oh, it's 2 p.m. also. And that this hit. Okay. Can you see what I've done? I've already made out the stage. I made out it's starting to dissipate, friction over the land, whatever. Okay, because I see when it's over and there's my cyclone here, my tropical cyclone. Can you see it? It's over the land, it's much faster. Over the sea, rather, it's much faster. And as it's going each day and it's moving in, it's decreasing in speed. Okay, now let's go through this tropical cyclone, Idai. That's what it's known as. Idai gives us already, tell us A, B, C, D, E, F, G, H, I. Can you see? 9. All right. I hope I'm correct. Well, the English teachers again will sort me out. Okay. A, B, C, D, E, F, G, H, I. So I think I'm correct. All right. As quickly strengthened, it's a 9 side, as quickly strengthened into an intense tropical cyclone. Okay. Right. We know it's very strong. And quickly it went in. It has been fluctuating, changing in intensity over the past 48 hours. Possibly changing here. Can you see it as it's moving over the land? It's not so strong. I'm just assuming. Remember, I didn't look at this paper also for a little while now, because I want to enjoy it with you and look at the strategies with you. Okay, so that is why we're going to work together. All right. An intense tropical cyclone is equivalent to category 3. Why is this examiner giving us this? An intense tropical cyclone is equal to or is equivalent to category 3. So he's telling us category 3 is an intense cyclone. Okay. Idai is slowly moving in a westerly direction towards Mozambique. You know, you already picked up, it moves from east to west with wind speeds exceeding 100 kilometers per hour closer to the eye. It tells you that closer to the eye, the wind speeds are greater, meaning the pressure gradient will be greater there, isn't it? Okay, can you see what's happening here? We're reading into this, and I promise you, you will get some answers from this. It is expected to reach the coastal area near Beira, Mozambique's fourth largest city, with over 530 residents before midnight. Whoa, 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 whoa. We're going to have some negative impacts there. Okay, can you see we explored it? Now, we don't take so much time, and the more you practice this, the quicker you'll be able to identify things. So we built a whole story. We've got so much information. Okay, let's go to the questions, and then I'll look at the memo, what they want. All right, refer to the article with what do you compare an intense tropical cyclone? Can you see again, learners? What do we compare it with? Category 3 hurricane. Can you see it? Let's look at the memo. Category 3 hurricane. We took it straight from the article. Okay, can you see straight from the article? Right. So that was not a problem. One word. Okay. Name one condition that is necessary for the formation of tropical cyclone Idai. How do I know what formed tropical cyclone Idai? It's a tropical cyclone. So look at the question itself. It may bring it specific to Idai, but all cyclones have the same conditions necessary for the formation. So examiners try to make it a little bit fancy there, but they have a right to. You understand? You need to know that it's not in the article. You must write the general conditions that happen. Can you see it now? Again, a technique, learners. All right, look at it here. Sea surface temperatures above 26.5 degrees Celsius. You learned all these conditions, isn't it? Unstable atmospheric conditions. So air is moving up, pressure is getting lower. Originates between 5 and 25 degrees north and south. Okay, because at 0 degrees, there's no Coriolis force. Okay, so therefore it will occur. Can you see it? I'm not going to go through all the options, learners. I want to cover as many different types of resources and questions with you so that you get more techniques in climate and weather. So I'm going to do 4 options, sometimes 3. Can you see it? And of course, you know, for Coriolis force to happen, for the winds to be deflected and move east to west, okay, because it happens in the easterly wind belt, the easterly trade winds, and it has to be deflected in order for it to move. Can you see? You know all that, right? Let's look at this one. Refer to the image and determine the expected wind speed with tropical cyclone, which tropical cyclone Idai will reach the coast of Mozambique. With what speed it will reach the coast of Mozambique. Remember the words coast now, learners. Let's go back here. All right, let's read. We did highlight. The resource we did highlight. And we see, oh, there's Mozambique written here. There's the boundary. So this one seems to be the closest, eh? It's about 120, but 150 seems to be there also. It seems to be between 120 and 150. Okay, what do I write there now? Do I write 150, 120? All right, but it hasn't reached the coast there. So I have to exclude this one. Okay, but this one seems to be more correct because it's on the coast. Okay, but you'll notice what happens, all right? And you'll notice here what it says, 120. Okay, but it's not right there. So the examiners have to accept 120 to 149. Can you see it? If it's there. These challenges do arise. Sometimes we get it on the point, but if we don't, it's okay. Only problem is you do not write 150, because 150 clearly tells you it's on the ocean. Okay, can you see how it's important to look at this? Why will the wind speed decrease as you move further from the eye? Now this question, whoa, do I have to talk about, but I didn't actually know this curriculum hasn't stated it that well. The rising air, warm air, and reducing the pressure on the top, displacing the cold air, blah, 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 blah. You understand? Do I have to write all that? I heard somewhere they said this. No. We're sticking to curriculum issues. We're using what you know about wind speed decreasing. We're using this telling us the intensity, all right, near the eye. Okay, closer to the eye is stronger. So therefore we're relating to pressure gradient. So yes, you don't need to know all those major things. You say, but no one told me about this. No, you answer it, all right? So that you eliminate the challenges that you have. Simple answers. The examiners know that you didn't go in that depth, but basic stuff. All right, let's look at the basic stuff here. The pressure gradient decreases when we move away from the eye. Okay, that will decrease wind speeds. It's a basic thing. So yes, there were challenges, but you know now it reduces. Okay, or isobars are further apart as you move away from the eye, because when that air gets displaced up there, the cold air gets displaced, etc., when the warm air comes in, reducing the pressure. But I'm not going to worry you with all that, because now you feel very scared of geography. That's the full explanations. But the examiners have brought in and made it simplified with concepts that you are familiar with. Okay, the pull of the vortex becomes weaker because air rushes towards the eye, and as you move away, obviously the pressure will increase compared to the eye. Can you see? So simple answers. All right, let's go up and look at the next question. 1.3.5, explain how the dangerous semicircle of tropical cyclone Idai originated. Whoa, do I have to talk about translation speed? All right, and the rotation wind field and how they add together to increase this intensity of the danger semicircle? Wipe out those words from your head, what I told you. All right, and that's now the experts in giving, and of course that is your full answers. Okay, but the examiners know that you haven't gone to such depth as a climatologist or a meteorologist, so the answers are simple again, what you've seen on your stuff. Okay, maybe a little bit vague, but it's simple again. You understand? So the examiners know, so you answer it the way you see it. All right, like for instance, I like this one. Okay, it doesn't talk about translation speed and rotational wind fields, etc. I always love to talk a little more in my class. All right. Intense winds in the cyclone combines the force of the entire cyclone moving forwards into the left-hand the intense winds in the cyclone combine with the force of the entire cyclone moving into the left-hand quadrant. You understand? The intense winds that's happening, yeah. If it's southern hemisphere, it's moving towards the eye. So we're getting these strong winds. Plus, it's right here. And remember, the force of the movement of the tropical cyclone also will make that part, the forward left-hand quadrant, very, very intense. Okay, and you must know it's the forward movement and the circulation happening as it moves in that direction. It's happening, it's coming, and there's it in the front here. Okay, wind shear, I know a concept. Where did we deal with wind shear? And is it a sudden change in wind direction only? Okay, you may have come across the word wind wind shear, it covers wind direction, wind speed, it's horizontal, it's also vertical, but you never touched on it. So you don't need to worry about the examiners have simplified it, and they make it a sudden change in the wind direction at lower altitude, which intensifies, because at lower altitude the air is moving and rising. That is why wind shears are vertical and horizontal. Okay, but what I want to say, these questions may have gave you challenges. Look at the simple ways in terms of how you would answer it. That it's here, it's right down here. Okay, this whole cyclone movement plus the circulation combined to create that intensity. Okay, so even though you may have challenges, you know you can handle it if you learn how to apply. So yes, in these two questions, oh, I know I've met people and I've met learners over, not necessarily my learners, but what happened here? You understand? You can simplify and get it. Okay, so you don't have to mention the translation speed, etc. Okay, now let's look at the last question here. A paragraph of approximately 8 lines suggests the negative impact that high wind speeds will have on the coastal areas of Mozambique. High wind speeds, specific to winds, all right, specific to winds, okay, and specific to the coastal areas of Mozambique. Now, learners, I know it is also spoke to about scaffolding of questions. You sometimes get the image, hey, 1.3, maybe 1.34 will be easier than 1.35, and 1.36 is the paragraph. Whoa, I do not touch the paragraph. It's too difficult for me. You understand? I'm going to leave it. It's too difficult. Forget it, learners. You read everything. It doesn't necessarily mean that it's a higher order question, that the level of difficulty will be considered very difficult. We can get higher order questions with a lower level of difficulty than a middle order question. So we must remember that. Don't just have a psychological thing about paragraph questions. This is actually not a difficult one. It's high wind speeds on the coastal areas of Mozambique. Simply done. Look at the answer here, and tell me you couldn't answer this. Okay, storm surges due to strong winds will cause floods. Okay, all right. Damage to property because of flooding and strong winds, but more the strong winds, but the strong winds also bring in the water. Can you see? Loss of life, but you say due to strong winds, houses getting broken. Okay, everything is happening. Causes injury to people and animals. It'll cause coastal erosion, isn't it? When the strong winds come, it'll erode the area. Destruction of infrastructure. You can give examples, roads, etc. Can you see what I'm doing here, learners? Is it difficult? The strong winds are going to kill people. They're going to damage property. And it can cause injury to people, animals, whatever. Ecosystems can be disrupted as trees fall, etc. Habitats of people, of them, plants are lost. Okay, tourism, you can see the answers here. Of course, you get the 29 paper and look at it even more. I want to do more examples, so I'm not going to do all. But what I'm trying to say here, this is a paragraph question, but it's not a difficult paragraph question. Okay, the main words you looked at was negative impact. It's based on the strong winds and it's based on the coast of Mozambique. So in your answer, I'd like you, maybe these may not be accepted, along the coast, you understand there'll be damage to property as the strong winds blow and destroy houses. Can you see? That's all I want you. I want you to put it in full. Okay. Trees falling or house destruction can result in people dying, you understand, or injury. Strong winds blow and cause coastal erosions. Okay, damage the roads. Can you see it? Along the coast. Okay, so it's simple, learners. It's simple. Okay, look at this paper in full, at all the memos, eh? You don't forget. Right. So what we're learning, there's nothing difficult, eh? Or even those high order questions. In fact, those 1.36 was easier than 1.34 and 1.35. You've done it all the time. Just make it specific to the coastal and the winds. Okay. Now here, South African Berg winds. Already what's going through your mind? Air moving down and heating up adiabatically. What do we see on the diagram? A Kalahari high pressure system is well developed. Okay, so, and what do we see here? The air is moving down the escarpment. Okay, it did not give us a coastal low here, all right? But if it's moving there, there has to be a low pressure here. Now, you may be used to seeing a coastal low. You understand? I don't see it. Maybe it's there. And, oh, somebody's going to hit me and say it was there. But still, you can answer this because he spoke about the Berg wind. Can you see? So something, but there's no coastal low. But you know, in a Berg wind, you must have a coastal low. So it's not necessarily to put that information there. All right. Warm offshore wind moving from land to sea. So everything starts going through your head. Eh? As it comes down, there's adiabatic heating. All right. Moisture gets evaporated. Okay. And therefore it comes down as a warm, dry wind. Okay. Can you see it from the central plateau where it's 14 degrees Celsius, and look at the temperature here. You see what I'm doing? I'm learning to use the resources. And examiners give you enough little tips on your, I call it tips, all right, on your little resources that you can use. Okay, so let's look at the questions. All right. Which season do South African Berg winds develop? Now, I know most of you just know it's winter, but you can also work it out. A well-developed, if you forgot, a well-developed Kalahari high happens in winter. Can you see it? So you work it out. Can you see it? All right. So obviously it's winter. Okay. Let's look at the next question. Give two pieces of evidence to support your answer. Giving evidence from figure 1.4. All right. You can't just give your general answers. That is why you must read, learners. You give the right information. All right. So what do I see here? All right. I see a well-developed Kalahari high-pressure system. A well-developed. Can you see? I see air moving down towards the coast. All right. Offshore. All right. Let's see what they ask, what they give us. Presence of a Kalahari high pressure. I want you to write a well-developed Kalahari high pressure system. Examiners are always nice. They look at giving you the answers. I want you to write a well-developed Kalahari high system. Yes, it gets displaced, etc. in summer, but it's there. So I want you to write well-developed. Lower temperatures. Can you see 14 degrees Celsius? Movement of air from the Kalahari high towards the coast, and all that is in there. It's about applying your work. Can you see? If Berg winds come out or don't come out, it's not the issue. You've learned you can do it in any section. You can apply your work. Okay. Offshore winds are more, eh? If it's coming from the internal, I know you get offshore, onshore, land and sea, whatever, but it's happening there. It's visible in the diagram, so we have to use it. Why not? Examiners must give us that. Can you see again, as I say, I'm not going through every answer, but can you see how we can answer it by using our source? Now let's look at this. Why are Berg winds described as being dry? Can you see? It makes you think a little bit, hey, scaffolding. Not difficult. You've already learned. As air comes down, it heats up adiabatically. There's evaporation because the air is heating up, so the moisture gets evaporated, making it drier. Okay, and of course the examiners will give us other options. As air descends, moisture evaporates. Can you see it? Okay, very little moisture because it's carried from the interior. It comes from land to sea. Therefore, it's less moisture. If it was coming from sea to land, then of course, if it was coming from sea to land, then obviously you're going to get more moisture, but this way is coming from land to sea. It's an offshore wind. Can you see how we worked it out? All right, it originates over land. Okay, now let's look at the next question. What causes South African berg winds to be warm? Offshore wind. Can you see it? A warm offshore wind. You know, as it goes down the escarpment, it heats up adiabatically. Okay. And then it says, yeah, air heats up adiabatically as it descends. Correct answer. They give you even an alternate. It increases by 1 degree Celsius for every 100 meters. Okay, that's a dry adiabatic lapse rate because it's dry air. But the main one, as it descends, it heats up adiabatically. Can you see that? All right, let's go to the questions. How does a steep pressure gradient influence South African berg winds? Of course, it's relative to the temperatures, etc. Let's look at it here. It will result in a rapid, strong increase in wind speed, okay, because the pressure gradient becomes steeper, and it will heat up quickly because as it's going through steep, you understand the adiabatic lapse rate of 1 degree Celsius for every 100 meters, it's going to heat up quickly. Okay, because it's steep, it's going to come down, height is changing quickly. All right, so it's going to heat up quickly, or because it's there, it's actually resulting in a strong wind. Logical answers, learners. Remember that it's this gradient coming down, and for each 100 meters is changing, and this escarpment is large. You understand? Okay, now look at the next question. Why are emergency services? Now, Sam has brought a different perspective here. You say, oh, my teacher, oh, I didn't worry about, Mr. Dave didn't teach us about fire brigades, ambulances. This is what my learners may say. Fire brigades, ambulances, traffic police. What's this traffic police and things? Okay, and then you get very annoyed, but look at it. Read the question. Examiners have to put it in a different way, but it's an answer that you know. Okay, emergency services are fire brigades, police, are placed on high alert when berg wind conditions occur. Can you see it? What does berg winds bring? That's what we need to look at. Berg winds can cause veld fires because it's a dry wind. What happens when veld fires occur? Don't you need somebody to put it off? Don't you need, in case somebody gets burnt, an ambulance and then traffic officers to move them around? Isn't it a reality? You understand? But you don't have to really worry about all the traffic officers. The examiners have made it interesting. It brought it to real life situations. So look at the answers here, learners. Berg winds dry out vegetation, all right, which makes it flammable, which can burn. There is a responsibility that a possible fire can spread quickly, causing destruction over large areas. So houses can get burned down, isn't it? Don't you need the fire department to come in, all right, to save, fire brigades, etc., to come in, or emergency services like ambulance if somebody is injured, isn't it? Can you see it? Outbreaks of fire could harm people, skin burns, isn't it? You need the doctors. High temperatures can cause dehydration amongst children, etc. Can you see the answers? Now you know the effects of veld fires, etc. But the examiner brought in making it more realistic with the fire brigade, the emergency services. So nothing is difficult. And that was the questions there. Can you see it? Okay, I'm not, as I say, I'm not going through all. What is this? Mid-latitude cyclone. Okay, I've read it. Oh, it says stages of development and related weather. Okay. I see a large cloud here. Cumulonimbus, rainfall. Okay, what happens here? Oh, so this is my cold front. Can you see? There's the cold air here. This will be the warm sector. Okay, so this will be the warm front. I'm getting it. oh, this smaller cloud here, I remember it was nimbostratus, whatever. You understand? Okay, so I'm working out things. Here I can see it's undercutting the warm air. It's moving, yeah. The warm air overriding whatever, depending whether it's your warm or cold occlusion and things like that. But I'm not so 100% yet, but I can visualize in case they ask, all right? But this is not related to that. It's basically a cross section, okay? So I'm thinking about all that now. I must exclude it from there now. It's not really showing me the occlusion. But can you see I'm thinking about it? Okay. Can you see I'm working at it, showing me just a cross section, all right, of the mid-latitude cyclone. So no, exclude occlusions from here. Okay. Right, let's go on. Look at this now. Various options. This is a multiple choice question, learners. Various options are provided the possible answers for the following questions based on the cross section. Can you see? It's a cross section. Okay. Choose the answers and write down only the letter next to the number of the question. Can you see it? Okay. Now, obviously, let's look at it. And it's simple, learners, but think about it. The general direction of movement of a mid-latitude cyclone in the southern hemisphere is, all right? You already know that it moves from west to east, okay? But that is where you look at your differences, learners. You take the mid-latitude cyclone and you take the tropical cyclone, all right? And you must know the differences. Some of you make silly errors with this. Can you see it? You know mid-latitude cyclone from southwest to northeast or from west to east. Okay, so obviously it moves eastwards. Identify cloud type A, all right? And if you look at cloud type A, let's go up, you know what it is. Okay, it's your nimbostratus cloud. Can you see it? It can't be your cumulonimbus, all right? You've learned that off. Okay, so very basic questions. Refer to the area at B, all right? Let's look at the area at B. You already worked out it's the warm sector. Can you see it? The warm sector. So can you see you have to make sense of your cross sections or your resources. It may look different to the one in your book in terms of the way the diagram is, but there's similarity. Cold front, warm front, whatever. You can still work it out. So it's not learning out notes, but it's applying the notes. Okay, so you know it's the warm sector. The type of cloud, apologies learners, at sea. The type of cloud at sea. And look at C, you see this anvil-shaped cloud? You see, I know my stuff now because I've applied it. Is cumulonimbus. All right, that's C. Okay, and let's go on. The gradient at D, okay? The gradient at D, look at the gradient at D. You can see it here. Even gives you a tip when you look at this. All right, it's steep, it's not gentle, it's a cold front, which is wedging, all right, under this warm air and pushing it up. You understand? So you know that that is the pressure gradient is steep, and the answer will be A. Can you see? It's not guessing, it's working out. What front is found at D? All right, you know what front it is already. The cold front, because you recognized all that. All right, and obviously the cold front. Can you see you work out these answers, learners? All right, let's go on. Apologize. The more active, faster moving front is the, you know it's a cold front, all right, because it's coming in and wedging. Okay, so that is a cold front. All right, all these become simple. The type of rainfall at E. Where's E? I know some people start thinking, whoa, it's heavy rainfall. Look at your options first because there's a front coming in. You've learned about the Western Cape. When the front coming in, it's known as your frontal rainfall. Okay, because the question said type of rainfall. Light showers? No, because it's a cumulonimbus cloud. Frontal rainfall, yes. Okay, if I put in heavy rainfall, I may have a problem. So I can't include frontal rainfall, light showers, frontal rainfall, orographic. Is it going up a mountain? No. Convectional, is there intense heating? No, it's a cold front. Can you see? Another thing that comes out from this question, learners, is to read all 4 options when it comes to your multiple choice. All 4 options, because there has to be distractors. Distractors are there which look very close to the answers. But sometimes it may not be even close, but if you don't apply your terminology, you may choose the first option, but the more correct one would be the second option. Can you see it? It's strategies again I'm emphasizing. All right. Okay. Let's look at this, learners. And I think for this lesson, we may just have one more thing to answer here. Okay. This again gives us a tropical cyclone. It shows you it's moving in. And you can see here, learners, the isobars are getting further apart. Forward left-hand quadrant, because it's moving over land. It's dissipating. All right, isobars are far apart. Yeah, it's over sea. It's closer together. Your symbol, okay, Bera is number 2. Okay, the second cyclone to hit the area. Okay, what else do I see here? I see, whoa, there's a low pressure here that is talking about. That's the thermal low. Can you see it, how I'm working it out now? Because it's more or less like summer. I'm looking here. There is a bit of a coastal sort of low here. I'm looking here. I may say, ooh, this shows me down here. These temperatures don't really make sense. It's a challenge for me. There's one thing I want to tell you, learners. Sometimes things may just happen that it doesn't comply in terms of the wind direction or the temperatures or whatever. Okay, when you come across some that, and maybe your educator taught you this is what the wind speeds will look like, this is what the temperatures will look like in your map, and they are correct. Sometimes these things do pop up. So do I say, I'm not going to answer it because this doesn't make sense to me? It may not, but you answer it the way you see it, learners. Very, very important. Answer it what's there, because if it's a little challenge in the resource, you understand, then of course whoever is looking at these memos, whatever, would make an adjustment. So yes, if we say sometimes it could be a gremlin, okay, it still doesn't mean you can't answer it. Okay, so there could be challenges. All right, so let's look at how we answer it down here. And you notice you can answer all these questions, because there's some nice questions. There are nice questions which are relevant. Okay, so let's look at the questions. What are lines representing the air pressure on a map called? Okay, can you see how nice the examiners are? They don't kill you. They bring in some nice, simple concepts. Isobars. You understand? Okay, you know it already. Give 2 pieces of evidence that the season depicted is summer. Okay, you're seeing here. All right, there's various things down here. The date, which is maybe heading towards autumn, but it's closer to that. I'm seeing more here, tropical cyclone. All right, I'm looking at temperatures, the general temperatures. You'll see a high. Can you see it? Okay, so I'm looking at various things, and let's look at what the examiners give us. Low pressure, thermal low, as indicated here. All right, can you see it's formed? And you know that happens in summer over the land. Okay, that's more than the high pressure, intense high pressures. Can you see it? The date 28 March was given. I know some say, but is it autumn? Is it this? But examiners are nice people, eh? They try to give you as many answers as possible. The presence of the tropical cyclone, high temperatures over the interior. Can you see it? It's marks. It's simple things, learners. You can't lose marks about that. Okay, even they gave the position of the South Indian and South Atlantic eye. Well, it's not so clear here, but it's more in the northerly position. You know, it follows the ITCZ. Okay. State the general movement of the air pressure cell A. Right. Air pressure cell A. The general movement, not the circulation. Eh? All right. Look at it here. Along the coast. From west to east, isn't it? It's, you've learned it starts from there and it moves along the coast from west to east. All right. I know, learners, you know this, but you mix up. It says movement. You give us circulation. It is clockwise because it is a low pressure system. Watch out for that. That is why it's important to highlight the word movement, not circulation. Be careful, eh? Refer to air pressure cell B. Okay, there's B here. You know it's your thermal low, eh? All right. And it says, name this pressure cell. Can you see it? You got it here. Heat low or thermal low. All right. Because it's associated with the heat down there. Air is rising because it's hot, and therefore it's making it a low. Explain how air pressure system B influences the summer rainfall pattern over the interior. It's not now specific to that. You know, air is rising to create the low pressure. All right, air is rising to create the low pressure, and as it rises, okay, it's going to cool, form, condense, and if there's lots of air to create the heat low, you know the process already, isn't it? So look at the answer. Land surface is intensely heated. That's what's associated, causing warm air to rise. High evaporation rates. All right? Can you see it? Okay? Condensation results in dense cloud cover. Okay? And each time you learn the technique here, try and put a conclude it. But sometimes there's so many points, and for each thing you mention, you're getting 2 marks. So sometimes it may not be the whole process, okay, because there's so many steps involved. But if you put 2 fully explained steps, you are still fine, okay? You know, okay, it leads to the formation of clouds and therefore dense cloud cover because of all this air evaporating and rising, isn't it? Can you see, learners, how brilliant that is? You know it. And examiners have to make it interesting. They bring in the sketches. Geography is not such a difficult question, or subject rather, not just a question. Refer to weather station model C. Now, I may have questioned, or you may have questioned the temperatures, wind speed, whatever. Forget that. It's there. You understand? And examiners will test you so you can answer that. Can you see? Give evidence from weather station model C that suggests there's very little rain, okay? A little possibility of rain. Now look here, learners. Cloud cover. Don't you all know cloud cover? All right, okay. Lower temperatures, offshore winds. You've learned that. Now I want to show you this instead of, worrying about it. Can you see cloud cover? It's 208. You understand? Okay. The wind coming through at that point, it's coming clockwise. It's moving from land to sea, isn't it? So less moisture. Can you see? You can answer these questions. All right. Lower temperatures, so less evaporation. Okay. So I'm teaching you a technique. Sometimes we have these challenges. Ask yourself, instead of saying, it doesn't make sense to me, ask yourself, can I answer this question? And you find you can. In fact, sometimes because of a certain challenge that you may consider it a challenge, okay, I'm not saying it is, but you may consider it a challenge, the question then becomes easier and it benefits you. Okay, right. Account for the air temperature and wind direction recorded at station C. I want to show you this answer. It's air temperature, All right, anti-clockwise movement. Oh, sorry, let's go back to C. All right, in this area here. All right, and it says, I do apologize for skipping all the time. So air temperature and wind direction. Okay, now anti-clockwise movement of air from high pressure to low pressure cell brings cooler air onto the land from high pressure to low pressure cell. You've learned that already. So the air temperature. All right. South Atlantic high pressure reaches over the land. Okay. Because there's a low pressure there now. Remember, air moves from, there's the low pressure here. And there's the high pressure here. Can you see it? All right. It's moving across. Can you see that? All right. So it brings in cooler air onto the land from the South Atlantic high. Can you see it? And of course, wind direction, again, because it moves anti-clockwise here and it comes across. All right. Movement of air. So the wind direction is influenced by the anti-clockwise movement of air in a high pressure system. It's moving anti-clockwise. That's how the wind direction is affected. Now, you know all this, learners. You know all this. All right? So what is the issue here that we find sometimes? Okay, and look at the question. It says, account for the high temperature and wind direction. What do learners sometimes do is they give the temperature and the wind direction. Okay, they do not, if there's a temperature indicated nearby, they say, let's use an example, 29 degrees, wind speed 20 knots, whatever. The question states, account for the air temperature, not state the air temperature. You have to identify whether it's high, low, and what happens. You understand? Why does this temperature go down? Can you see the difference? The word account. Can you see it? And that is why you got the answer like that. You understand? The wind direction, anti-clockwise movement of air in the high pressure is influenced by that. It brings in cooler air on land. Can you see it? As clockwise moves from high pressure to low, or the South Atlantic high is moving. Can you see that? Okay? Right. Very, very important. Learners, I'm going to take a chance and then look at this. Right. And I'm not going to complete because I try to keep my sessions for 1 hour. All right. Let's look at this. Differences between rural and urban climates. All right. The average summer temperatures. Okay. What's this? You can see crops, etc. Rural area is 22 degrees. What do we see here? Massive buildings, etc. Can you see it? Temperature is 32 degrees. So it's telling us that the urban area is warmer than the rural area. Can you see it? Just doing a strategy. I do apologize, learners. I may not finish this one, but just to show you another way of doing it using pictures. So we're talking about urban heat islands, etc. here, isn't it? We're talking about these multiple reflections between the buildings, the concrete, steel, and tar, the human activities. You understand? It's a lot of people. Yeah, it's far less. Basically that. That's what the examiners are wanting you to identify. That's why you use the word, or she used the word, rural-urban climates, making life easier for you, giving you a vision. Look at the questions. Will A or B generally experience lower wind speeds? Right, I'm just going to go through it quickly. A or B? Of course, A is open. If wind blows, it's going to blow through. Yeah, B will actually have these buildings that will slow down the winds. All right, the tall buildings, you learned it in class. It's about taking the fact here. It's related to wind speeds and taking your general factors and putting it into context of the question. Can you see it? B. All right, look at this one quickly. What evidence in the photograph indicates that A experiences a higher evaporation rate than B? Okay, now look at it here. More evidence of clouds. Can you see it? that tells you about evaporation. That is why it's important. You're finding your answers in the resources. You observing that there's more cloud there. Can you see it? What more vegetation causes more evapotranspiration? Vegetation. Therefore, more evapotranspiration, more rising air. You understand? More moisture, more that. You understand? Okay, I'm just doing some things. Let's look at the next one. Why does B experience more frequent rainfall than A? You know that B here, air moves from higher pressure to low pressure, from the rural areas to the urban areas. It's HP here, all right? And it's LP there, lower pressure here because it's warmer. Right, air moves from there to there, bringing in the humidity. Although there's less rain, there's less moisture here, more here. It brings in, when it moves from a higher pressure from the colder rural areas to the warmer urban areas, it brings in moisture. There's more dust particles. You would have learned all this. I know you've got brilliant teachers also. All it's doing now is taking it and putting it into context of you identifying that as an urban area, that as a rural area. And that is what the examiner wanted. Eh? Good, eh? Isn't it? So look at it down here. There are more condensation nuclei in B, all right, or hydroscopic nuclei. And also the fact is that it does bring in the moisture there, okay, to the urban area. But there was more specific the examiner wanted was basing on why that area, okay, experiences more, because there's more dust particles. That was the main emphasis of the examiner. Because there's more dust particles, water can cling to more of these dust particles, creating more droplets of water. Okay, let's look at this one, 244. Explain the geometric shape of the buildings and in the city that causes great absorption of heat. The geometric shape, but whatever, you understand. There are tall buildings which cause the sun's rays to be reflected. Can you see? Again, it's bringing it in with the context of one factor, the geometric shape of the buildings. Okay, and you know what will apply there? Multiple reflections. Okay, a larger surface area to absorb the sun's rays. You can see clearly here. Look at it. Always larger surface area to cover, even here and here. You understand? So more heat is absorbed. Can you see it? Okay, I think I'm going to finish this, and I'm sorry, I'm going to use a little bit more of your data when you're watching this. Okay, I did rush a little bit through this, but I know when it gets over an hour, it's too long. All right, in a paragraph of approximately 8 lines, discuss how artificial surfaces, all right, yeah, and urban activities contribute to higher temperatures. So it's just 2 things here. It's not everything else. It's not all the other factors that come through. It's human activities and artificial surfaces. So all your answers must relate to that. Can you see it, learners? Not difficult. You've answered this. You understand? Artificial concrete, steel, tar, whatever absorbs more heat. The human activities in the city, you understand that's going on. Look at it here. Artificial surfaces. Concrete metals are used for the construction of buildings, therefore more heat is retained. You know if it's 42 degrees Celsius, go walk on a tar road. Please don't do it. All right? Don't try this at home. Okay, you will burn. Can you see? Glass and mirror surfaces. Okay, you're talking about the artificial surfaces. Urban activities. Urban areas are generate more heat through activities. Air conditioners are working in restaurants. They use more appliances, stoves, air conditioners. All right, not that there's no air conditioning in the rural area. Some people could have, but more generation of heat. Then industries, all right, produce heat. Okay, in the area, all right, in the urban area, all right. Vehicles that travel pollute a lot. Okay, so learners, I know I went a little bit more, so I do apologize for going a little bit over the hour. All right, there's so much on the strategies. We looked at it today. There's nothing that's difficult here. It's about applying it to the resource. You understand? It's about looking at the strategies. It's also about looking at the mark allocation. Anything, if it's 1 times 2, means we want a good explanation, a full explanation, because this determines the explanation. All right, the 2 marks, and the 1 mark determines how many factors you must explain. Okay, very, very important. Learners, I hope it helps you with your climate. All right, remember, it doesn't mean these things are, there could be anything else coming out, but you know how to apply it. All the best, learners. Goodbye.